Calibrating time-dependent one-year relative survival ratio for selected cancers in Canada. This presentation is based on our publication in the Lobachevsky Journal of Mathematics. I will start with the background of this study. A relative survival ratio for cancer is the ratio of the observed survival in cancer patients to the expected survival of a group of similar non-cancer individuals, in practice, the general population. Relative survival ratio is the preferred measure for cancer survival, and the 5-year ratio is often chosen as the primary measurement of analysis. However, the time-dependent one-year relative survival ratio for patients at risk can be used to predict the risk of mortality in the following year for cancer survival, and also is the desired parameter input in some situations, such as when using a yearly cycle in the Markov decision analytic model. Based on the published data, we demonstrated methods to approximate the conditional one-year relative survival ratio from year 1 to year 9. The table shows the published 5-year relative survival ratio conditional on having survived years 0 to 5, and 1-year relative survival ratio at year 0 for 6 selected types of cancers and all cancers. We will use these data to calibrate time-dependent 1-year relative survival ratio in Canada. The methods illustrated below can be used for the data from other countries, or the time-dependent monthly relative survival ratio. Proof of the relationship between the cumulative relative survival ratio and relative survival ratio at each time unit. In summary, the 5-year relative survival ratio is equal to the product of 1-year relative survival ratios in the 5 corresponding years. Applying this proof, we demonstrated 5 methods to calibrate 1-year relative survival ratio, conditional on having survived years. Method 1. Under the assumption that 1-year relative survival ratio conditional on having survived 6 years or more is the same as that conditional on having survived 5 years, we estimated the 1-year relative survival ratios. This slide shows the results of 1-year relative survival ratio using method 1. Using the estimated 1-year relative survival ratios, we projected the 5-year relative survival ratios. Almost no projected 5-year relative survival ratios fell in the 95% confidence interval for the 6 types of cancers and all cancers. It is suggested that method 1 needs improvement. Method 2. We used calibration methods to correct rounding errors in publications, under the same assumption in method 1. We developed the acceptance criteria to select calibrated 1-year relative survival ratios, including 1-year relative survival ratio is less than 1, and 1-year relative survival ratio in a given year is greater than in the previous year. This flowchart describes the process of calibration. Results of method 2. We randomly selected up to 1,000 calibrated 1-year relative survival ratio sets. The simulation yielded eligible results for all cancers, leukemia, lung and bronchus, and non-Hodgkin lymphoma cancer. For method 1 and 2, estimations of 1-year relative survival ratios were based on the assumption of a constant 1-year relative survival ratio after having 5 years survival. However, under this assumption, we did not obtain eligible calibrated 1-year relative survival ratios for some types of cancers. We released this assumption in the following methods introduced. There are various ways to define 1-year relative survival ratios conditional on survival at 6 years or later. For method 3, we added an adjustment factor in estimating 1-year relative survival ratio. We assumed that after 5 years of cancer survival, the 1-year relative survival ratio would be equal to lambda, a constant coefficient, multiplied by the 1-year relative survival ratio in the preceding year, with an upper limit relative survival ratio of 1. Results of method 3. Except for female breast cancer and prostate cancer, we obtained calibrated 1-year relative survival ratio for the other 5 types of cancer. The uncertainty interval, minimum to maximum, of calibrated 1-year relative survival ratios can be very large, such as the 1-year relative survival ratios from year 1 to year 9 for lung and bronchus cancer. Method 4. We also used a second method with an adjustment factor to estimate 1-year relative survival ratio. Adapting the formula for risk to time t in survival analysis, we developed the following formula to estimate 1-year relative survival ratios. Results of Method 4. The results are summarized in this table. We obtained calibrated 1-year relative survival ratio for all types of cancers. Compared with 1-year relative survival ratios estimated in Method 3, the uncertainty, the range, of calibrated 1-year relative survival ratios was reduced substantially and narrowed over time. Method 5. We released the assumptions for applying adjustment factors. Then, we generated 1-year relative survival ratios conditional on having survived 1 to 9 years in accordance with the biological system. Under 2 remaining assumptions, 1-year relative survival ratios increase over time, up to 1, and the difference between 2 consecutive 1-year relative survival ratios decreases over time. We used the same acceptance criteria as that in Method 2, and randomly selected up to 1,000 calibrated 1-year relative survival ratios sets for each cancer. Results of Method 5. Under the fewest assumptions, we obtained the calibrated results for all types of cancers. The range of calibrated 1-year relative survival ratios reduced over time. The 1-year relative survival ratios at year 1 and 2 for leukemia, lung and bronchus cancer, and non-Hodgkin lymphoma cancer were rather large. Discussion. We selected 6 types of cancer and all cancers to calibrate due to the availability of data. We used 5 methods to estimate the 1-year relative survival ratios. There is no definitive answer for which method is the best. The choice is dependent on the nature of the disease and the feasibility of applying the methods. I recommend using Method 4 because it provides a clear trend of changes of relative survival ratio and can be extended to calibrate monthly relative survival ratios. Also, Methods 4 had a smaller uncertainty of calibrated relative survival ratios compared with other methods. Application of relative survival ratios in a health economic model. We can estimate the probability of death for patients with cancer, conditional on having survived years, and with their age and sex. Here is the timeline of this article. Thank you.